I'm going to try and get as many of these C4 videos done as I can, but I don't think I'm going to be able to do the whole of them. I think the next thing I'm going to do after the binomial video, though, is going to be one on vectors. So the first thing to do with binomial expansion is to make sure that you get everything up to the top. So what we're going to do here is we're going to bring this up to the top. So that's going to be 2 plus 5x to the power of minus 3. But the next thing we need to do for C4 binomial is to make sure that this first thing is 1. So what we do is we divide by 2. So we're going to bring the 2 outside. We're going to factorize the 2 outside. But if we do that, we've got to make the 2 to the power of minus 3 as well. And a lot of people forget how to do that. So we divide through by 2. So that's going to be 1 plus 5 over 2x. That's to the power of minus 3. And then what we've got to do is we've got to do the expansion up to and including x to the power of 3. So I'm going to do 2 to the power of minus 3 on the outside. Now 2 to the power of minus 3 we know is 1 over 2 to the power of 3. So that's going to be 1/8. So we're going to have 1/8 on the outside, which is that 2 to the power of 3. And then we're going to do the expansion. Now the first expansion is always just 1. Then the next thing is the power times by this thing. So you're going to have plus minus 3 times by 5 over 2x. The next thing we're going to do is we're going to have the power times by the power take away 1, which is going to be minus 4, times by whatever the x is squared. Now we have to do 5 over 2x, all in brackets, squared, and that includes the signs. Well, hopefully we'll have a negative one in the next example. And what we do is we do that over 2 factorial. So in theory, the first one should have been over 1 factorial, but 1 factorial is just 1, so we don't ever need to worry about that one. Then we do the next one. So it's going to be the power, which is minus 3, take away 1, which is minus 4, and then we've got to take away another one, because we did minus 3 times minus 4 last time. So, sorry, that's times by minus 5, times by the x. Now, by the x, I mean everything there. So it's going to be 5 over 2x. This time it's cubed, and over 3 factorial. So it's going to be 1/8 times by 1. The next thing is going to be negative. So if we simplify minus 3 times 5 over 2, or if we just do 3 times 5 over 2, because we know it's going to be negative, that's going to be 15 over 2x. Then we've got to simplify this thing here. That's completely up to you how you do this. I'd be tempted in my calculator to do, well, you know it's going to be plus because it's a minus times a minus, so it's going to be plus. I just do minus 3 times minus 4 times, and then in brackets, 5 over 2 squared divided by 2 factorial, which gives us 75 over 2x squared. Then you do the same for the next one. Now the next one is at minus times a minus times a minus, so therefore there's 3 minuses in there, so it's going to be a minus. And then you do 3 times 4 times 5 times 5 over 2 cubed. Make sure you put this one in brackets, 5 over 2 cubed, and then divided by 3 factorial. And if we do that, that gives us 625 over 4x cubed. So now what we do is we times it all by 1/8. And that will give us 1/8 minus 15 over 16x plus 75x squared over 16 minus 625 over 32x cubed. So that's how you do the binomials. So let's have a look at the 2015 question. Pretty much exactly the same, except it takes it one step further. So we've got to do up to and including x squared for this one. But at the moment we can't do the expansion because it's not 1 plus. So what we do is we take the 4 outside. But then we've got to raise the 4 to this power. So it's going to be 4 to the power of a half. And if we divide inside by 4, it's going to be 1 plus 5 over 4x to the power of a half. Now 4 to the power of a half, that's just 2, because remember the power of a half means square root. So that's going to be 2 lots of the bracket. So the first one is going to be 1. Then the next one is going to be the power. So it's going to be a half times by, then this whole thing is x. So times by 5 over 4x. Oh, I'll put that in brackets. The next thing is going to be the half times by the power below, which is going to be minus 1/2, times by this thing, the x squared. So 5 over 4x squared, all over 2 factorial. Now if you do that, it's going to be 2, 1, plus, oh, so that should have been times by half there. So that's a half times by 5 over 4, so that's going to be, oh sorry, that was that one there, so that's going to be 5 over 8x, plus, then we've got to do a half times minus a half times 5 over 4 squared over 2 factorial. So we can see that because we've got one negative sign there, that's going to be a minus. Doing that gives you 25 over 128. So another way to do this is to do the numerator. So 1 times 1 times 5 squared, that's going to be 25. And the denominator is going to be 2 times 2 times 4 squared, so 2 times 2 times 4 times 4. And then the 2's on the bottom as well, so times it by 2 factorial. And we get this. And then if we multiply that out, that's going to be 2 plus 5 over 4x minus 25 over 64 x squared. So that's how to do that one. So that's 2 plus 5 over 4x minus 25 over 64 x squared. So we've got to find the exact value of this when x is 1/10. So what we're going to do is we're going to simply substitute that 1/10 into here. So that's going to be 4 plus 5 times 1/10 is going to be 1/2. It's the power of 1/2. So it's going to be 9 over 2, the power of a half. And if you do that in your calculator, you should get an answer. However, if you haven't got a calculator that can do that, we can actually say that's going to be 9 to the power of a half over 2 to the power of a half. So that's going to be 3 over root 2. But we need it to look like this thing here. So we need to times top and bottom by root 2. That's going to be 3 root 2 over 2. So therefore k is going to be 3 over 2. So now we know that basically that k equaling 3 over 2 root 2 means if we substitute 1/10 into this, it doesn't give us the square root of 2. It gives us, so if I write it down to make it clear, 4 plus 5 over x equals 3 over 2 root 2 when you substitute in 1/10. So if you so the whole thing that we did in the beginning, the reason that we do binomial expansion is that we can get something which is close to the real version of this. So we are saying that 4 plus 5x to the power of a half is roughly 2 plus 5 over 4x minus 25 over 64 x squared. Then they're roughly the same. So if I substitute 1/10 into this, I'm roughly going to get the same if I substitute 1/10 into this. But what they're saying is for part C, they want you to substitute 1/10 into your expansion and then find out what root 2 is. But we know that if we substitute 1/10 into this, and we get 3 over 2 root 2. So anyway, let's get 1 mark by substituting 1/10 into this thing here. So if you stick it into your calculator, so stick this into your calculator and substitute in 1/10 for x. So if you do that, that's going to be 2 plus 5 over 4 times 1/10 minus 25 over 64 times 1/10 squared, so that's 1/100th. And we've got to add that up and simplify it. So it's going to be 2 plus 5 over 40 minus 25 over 6400 And then if you simplify that, you should get 2 and 31 over 256. So that's what you get when you substitute in 1/10 into our approximation. But we know that that actually equals 3 root 2, and they want us to find an approximate value for root 2. So what we do here is we say that our 2 and 31, 256 is equal to, I'd say equal to, roughly equal to 3 over 2 root 2, because we know that's what this equals. So if you want to get a value for root 2, we need to times by 2, then we divide by 3. So if we do our answer and we times by 2 and divide by 3, we should end up getting root 2 is roughly equal to 1 and 53 over 128, but they want it in top-heavy fraction. So that's going to equal 181 over 128. So that's what you need to do for this question here. So you need to be able to do the expansion. That's reasonably straightforward. We substitute in 1/10, and that was quite an easy mark to get. But the trickier part is making an approximation for root 2. And it's the whole thing with this is recognizing that when you substitute 1/10 in, you don't get root 2. You get 3 over 2, or 1.5 root 2. Which means that whatever your answer is, you need to divide by 1.5, and that should give you that there. Okay, so the 2014 take on the binomial expansion was this one here. So it's given you the original thing, it's given you the actual expansion, but they haven't told you what k is. So if I was going to do the expansion of this, it's already 1 here, so I don't need to bring anything to the outside. So the first thing is going to be 1. And the next term is going to be minus 4 times this thing here. So that's going to be plus minus 4 kx. And the next thing is going to be minus 4 times by the power below, so minus 5 times by kx squared all over 2. Now for the first one, for 2 marks, it says find the value of the constant k. We know that this thing here equals minus 6k. So minus 4k equals 6. So therefore k, in fact no, it should be just 4k because the signs are the same. So 4k equals 6. So k equals 6 over 4, which is 3 over 2, just like the 2015 paper. So k is k equals 3 over 2. So to work out what the value of a is, we're going to substitute, we're going to get rid of this k here. We're going to substitute in 3 over 2. So it's going to be minus 4 times minus 5 times 3 over 2 x squared over 2. If we do that, again, if we do the 4 times, we know it's going to be positive because it's going to be a minus times a minus. So we're going to do on the top, we're going to have as a numerator 4 times 5 times 3 squared on the numerator. We've got 4 times 5, then you've got 3 squared. And on the denominator, we're going to have the 2 squared, because remember it's inside the squared brackets. So it's going to be 2 squared on the bottom, then times by this 2 as well. That's all going to be x squared. So if we simplify that, 4 times, the 2 squared is going to cancel out with a 4. So 5 times 3 squared, it's going to be 45. That's going to be over 2. So 45 x squared over 2. So therefore our value of a is 45 over 2. And that's basically how to do the binomial expansion.